certified engineers that are here to encourage young people, especially young school leavers, to go into the field of engineering, because we know that when engineering is top-notch, nation will move to the first world country. My name is Ayorinde Olanipekun, and on this program we are going to be talking and interacting. My guest is already with us. He's joining us via Zoom, but we are going to be interacting as we used to. It's a time where you don't want to hear us, but just ask us questions also and answer our questions also. The program is sponsored by Prince Engineer Yemisi Shillon, FNSC, and our question for today that you are meant to answer is, what is the locus of points equidistance from 2 points? What is the locus of points equidistance from 2 points? That's talking about physics. So if you know the answer, please call us. Or you can go to all our social media handles as displayed on the screen. If you get it correctly, you get a prize courtesy of our sponsor, Prince Engineer Yemisi Shillon. And Folorunso, last week, Folorunso got our prize correctly, Folorunso from Abeokuta. But you have not called to claim your prize. So please, Folorunso, call this number 0703 161 1497. 0703 161 1497. Call Folorunso from Abeokuta and claim your prize courtesy of our sponsor, Prince Engineer Yemisi Shillon, FNSC. Today we won't take any of your time. We'll just take this very, very short break. When we return, I will introduce my guest, then he will take us on the topic for today. Glad to know that you are still there. My guest for today is Dr. Ayorinde Olanipekun, and he's an engineer and a lecturer with Federal University of Agriculture, Abeokuta. He will be talking about simulation, and he's joining us via Zoom. And he'll be talking about simulation in engineering. Dr. Olanipekun, welcome to Engineering and You.
Thank you very much. I'm very pleased to be here today.
So you have the floor now, Dr. Olanipekun, so you can go ahead with your presentation.
All right. Thank you very much, Yoratum. I am talking about simulation in engineering today. Just like it is with a kind of sickness. When people are sick, we say it is better to prevent sickness than to cure it. In sciences and in engineering, we make use of so many things. Like experimentation is one of the key things we do. And when we experiment, we want to ensure that we are able to see the outcome of that thing. But oftentimes, experimentation can cost a lot of things. If you are experimenting with things that have to do with the life of people, lives might be lost. And that is why it is better to prevent than to cure. Now, in engineering, when we carry out experimentation too, sometimes we might incur a lot of costs when we are experimenting. But by simulation, we can see how things look like before we actually produce the product. And that is why we talk about simulation in engineering. Experiment and simulation, they are different from each other. Experiments, you use real items in experiments, but in simulation, we make use of a computer or special equipment. Also in experiment, the aim is to find out the probability of getting a certain result. Whereas in simulation, we substitute it for an experiment so that we can get things done without actually, using real items. Also, in experimentation, we use it to attain scientific theories. Experimentations, we come to a conclusion and then say some theories, we propagate some theories. Whereas in simulation, we apply scientific theories in order to be able to get things done. For example, what is simulation? Simulation, it is a technique of representing the real-world process or system by a computer program. You can see a man here trying to view how some contents of the body is. That is the kind of thing that we do in simulation. It imitates the internal processes and not merely the result of the thing being simulated. It tries to see what is actually happening within that we cannot see. It is usually done on a smaller scale than experimentation itself. Now, to carry out simulation, there are some tools that are usually used in engineering and many other fields where simulation is carried out. I have, for example, here some fields of engineering that I have put there. We have electrical engineering, civil engineering, mechanical engineering, and biomedical engineering. See, in this world, each one has its own different simulation tools. And some of these tools, at times, might be used by two different fields of engineering. For example, in electrical engineering, we make use of Proteus for simulation of circuits, make use of MATLAB Simulink for simulation of many other things. Circuits involved, power systems, solar systems, and the likes. We make use of PSPICE. We also make use of LabVIEW. We make use of LabVIEW to simulate. Likewise, in civil engineering, they make use of AutoCAD, Revit, Civil 3D, and there's another one that they call the SketchUp. They use it for simulating some of the things that they do, the buildings, how does it look like, the structures of the building. In mechanical engineering, they make use of SolidWorks to create many things. The structures, 3D drawings of what an engine should look like. Autodesk Invention is another one that they use, and they also make use of Solid Edge for their simulation. In biomedical engineering, they make use of MedLink, Mimics, MedCAD, and SurgiCAD for simulating how things will look like while carrying out surgery. Now, simulations have benefits. What are these benefits? One of the benefits of simulation is that it helps us to be able to analyze the behavior of a system. When I say a system, I'm talking about, for example, an engine. How will it behave when it is subjected to a kind of experience, subjected to a kind of condition? It helps to optimize part design. When we are designing parts of an engine, simulation will help us to optimize it. It won't be too big, it won't be too small. We'll be able to do it in such a way that we will be able to conserve money, conserve space. Then it helps us to bring products in a faster way to the market, because what we ought to do using many experimentation, we would have used simulation to do most of it. Faster products to the market. Another benefit is it is used for solving complex engineering problems that are difficult to be done by experiment. optimization problems, power system problems can be.
All right, I think we are having the issues with Dr. Olanipekun there. Hopefully he's going to join us back any moment from now. Well, he was talking about
design.
Okay.
The design will be effective, and then it will not be so costly. You can see this is one of the design of a bicycle can be done using the simulation. And also down there we can see another design of circuits using simulation of the process and the products. Simulation helps us to have better understanding of the process and of the products. It gives us cost-effective testing of the design. When we have a design and we want to test it, if we want to use experiment, we waste many things. Some things will get lost, some things will get spoiled. But when we test it using simulation, it is cost-effective. It also helps us to have enhanced connectivity and automation. We can connect a part to another part to another part, and so on and so forth. It is one of the benefits of simulation in engineering. Another one that is very important is that simulation helps us to have improved products, innovation products, and helps us to have improved performance. Like it is possible, maybe through a research we're able to do something, and after doing it, it is in the raw form. You can use simulation to enhance its product innovation. You can change you can change how it looks, can change the direction, and so on and so forth. Can help us to know the placement of parts on the body of a machine. Simulation does that so that we can have improved product innovation and improved performance. However, simulation in engineering also has demerits. Usually people will say it, that when you look at the sky, no matter how white the sky,
all right, again, we had a little challenge with Engr Olanipekun there. He's talking about simulation and how simulation has been beneficial, spoke about his comparison with experimentation, spoke about
its results can be subject to statistical errors. There can be statistical errors at times. Then producing the simulation tool can cost a lot of money. Getting it may not cost too much, but producing it, developing it might be expensive. And the last two are that sometimes the results you obtain can be difficult to interpret. Interpretation of results can bring graphical results and so on. You must be able to interpret it. Without being able to interpret it, it can be difficult. That's a demerit in a way. And the last one is that it is non-transferable. The solution you have is unique. You can't just transfer it to another thing, because anywhere you are taking it to, it will be subjected to another condition. So that is one of the demerits. However, simulation is very good in engineering, and it also helps a lot of people to be able to get things done on time. Yes, it helps us to avoid wastage of money. Imagine, you want to design an aircraft, and you want to do it by experimentation. After designing it, you went to experiment, the thing crashed, people died, then you came back again to do another one to experiment, and people are dying like that. But by simulation, you can fly it, subject it to different conditions, stochastic conditions, deterministic conditions, and then you'll be able to see how it's going to behave. And that is why simulation in engineering is very important. And the knowledge of this simulation in engineering can even be a source of income for so many people. When you know it, when you develop interest in simulation and you know it, people tend to come to you, and they don't come, you don't do work for them for free. Money that you can have in your pockets. So if as a student you are willing to study engineering, it is very good. And simulation is part of the area you can look into, and it is applicable to all fields of engineering. Thank you very much.
Thank you, Engineer Dr. Olanipekun. Thank you so much for your time, thank you for helping us to understand simulation and how it works. But before we let you go, we want you to answer some few questions, if you don't mind. Does it mean that with simulation, experimentation is going to go into extinction?
Oh, no. Experimentation will not go into extinction, because we still have to use it to get some other theories to know how things are happening. But the theories that have already been obtained, we can apply them using using simulation, so that we will not be wasting money. We will have cost-effective products. So experimentation will still go, because there are still many things that are yet to be known. So by experimentation, those things can be known. But by simulation, the known things can be put into action to work, and then we'll be able to see how things happen. It shows it graphically, and it helps us to be able to know how things are happening. For example, in the body of an individual, sometimes it's very difficult to know what is actually happening, unless you have somebody that is dead and that they have to maybe dissect the body, that's the right word for it, and they will look at what is there. But by simulation, you can get things done by simulation. People can even do operations or understand what happens. So it won't go into extinction, but at least it will not waste life, it will not waste money with simulation. Thank you, sir.
All right, Engineer, I would like you to unshare, so to speak, your slide so you can see your face.
Okay.
Yes.
Thank you very much.
Can you do that for us before I continue with my next question? But before then, you can see on your screen, viewers, the question for the day. If you know the answer, please call us. It's a physics question. Call us and let us know who, if you know it, and we'll get you the prize courtesy of our sponsor, Prince Engineer MC Shillon. So, Engineer Olanipekun, I have like two more questions for you. First, is that how much of simulation are we using in the Nigerian engineering system? Is it more of an household name? Is it something that we just know about, or how much of the application are we putting to use?
All right. Well, right now, if you want me to talk in terms of percentage, or maybe in terms of area of its use presently in Nigeria, simulation is being used in the aviation industry. It is being used in education, in research. We make use of it a lot in research, because there are so many things we do not have. So it helps us to have a virtual laboratory. In most times, setting up engineering laboratories is very, very costly. But with simulation, it has really helped in research. People can apply different principles to different situations and see how it works, and be able to predict what is going to happen if it is done that way. So I can say it is really being applied in the aviation industry, in training students, and in research. It's really being applied, even in Nigeria here.
Okay, since this program is about young people and young school leavers, how can they take advantage of simulation, learning it and putting it to use? And use your own case study. You studied electrical and electronic engineering, and you went ahead to have a specialty in control system engineering. So how
Yes.
does it help?
All right. Yes, it really helps. Like, for example, when I was doing my PhD, I needed a laboratory to carry out experimentation on several equipment which was not available around here. So I had to resort to using simulation to get things done. Even though what I used for my simulation at that time, and it wasn't so common around here, and people, not many people knew it. I had to contact people in India, people in Australia and Brazil to give me insight and materials to use. And when I studied it, I was able to use it. Now, I want to encourage young students to love engineering and to study engineering. And also to apply simulations you can use simulations to do many things. You can use simulation to study how current flows, how current flows through a circuit, a simple circuit. You cannot see current, you can only measure it. But through simulation, you will see it. You will see how it is flowing, and so this is the direction it flows through. So it really helps. And they can learn it. There are tools online on YouTube, instead of watching films that are not contributing to their lives. They can try to watch educational videos on simulations that will help them to understand some principles that they have been taught in the secondary school, maybe in physics or in chemistry or in biology. So I want to encourage them to go for that. Thank you very much.
Thank you so much, Engineer Ayorinde Olanipekun. Thank you so much for this insight into simulation. And I'm sure the young people out there have learned one or two things and how they can learn how to simulate. Thank you so much for joining us on the program.
Thank you so much.
All right, and I want to say a big thank you to all our viewers for being there for us and for staying tuned to us to listen to what we've been doing all since ever since we started. It's nobody called us to answer our question. Hopefully by next week we'll roll out the question and see if one or two persons can call and win the prize, courtesy of our sponsor, Prince Engr Shilon. I want to say a big thank you to our sponsor too for paying the bills and making us to come to your pleasure every Friday. For the week, the question for the week is, how many times do we have summer solstice in a year? If you know the answer, please drop it on all our social media platforms and you get your prize, courtesy of our sponsor, Prince Engr Shilon, FNSC. I would like to say, follow on show that got our question last week. Please call the number that I've called earlier, or maybe I should call it again, 703 161 1497. Call that number and claim your prize. Next week is another time when we bring you fresh edition of Engineering and You. And until next week, my name is Ayorinde Olanipekun. Bye-bye.